Hello, everyone. Welcome to section 2.6. We're almost done with chapter 2, which deals with compound inequalities. So last section we talked about what are inequalities, and they are sets of numbers, right? Intervals, if you will. And the inequality describes what side of what number it's on and the condition of the set that we're talking about. So today we're going to talk about compound inequalities, which are inequalities that look like this, or they also can be written as x less than 3 and x greater than 1. That's one of them. That's the and then or is going to be like x greater than 1 or x less than 3. Okay, and then we're going to finally use them in applications. So let's get started. Let's start with the ands first. Let's say we have this here connected by the word and. And is an interesting thing to think about because now we're getting into set theory territory, which I really love. So let's say here you have this inequality, 6x minus 3 less than 9. Let's go ahead and solve for x, okay, which we know by now, 6x less than 12 divided by 6. Okay, we get x less than 2. So that's one of the conditions. And we need to solve the other inequality so that we get the other condition. So let's go ahead and do that. Subtract 9, divide by 2. Okay, so here are my two conditions. X is less than 2, but it also is greater than or equal to negative 2. Okay, so this is an and. Okay, using set theory, sometimes we say intersection. That's the same thing. If I was to graph this, I have negative 2 because it goes negative 2, 2. Those are my 2 points of interest. So this part of the graph says, hey, x is greater than or equal to negative 2. So technically it would be, if we were to think this by itself, it would be everything to the right of negative 2. And then this one would be everything to the left of positive 2. However, when we put them together, so let's say here, I'm talking about this forever, and then let's say I was going to write this in red, this x less than 2, it would be here and connected to the left because it's less than, and because it's an and, I'm actually talking about both, okay? So they both have to be true. So that looks like this, okay? Usually it's where they both intersect, okay? They stop here. Okay, so then interval notation, we would have negative 2, comma 2, open. Okay, let's do a couple more, or let's see what else we have. A little bit more here. So like we just said, solve each inequality, graph the solution, and graph the numbers that make both of them true. Okay, and then we write it in interval notation. So here we have 2x plus 5 less than or equal to 18, and 2 times the quantity x minus 7 less than negative 6. Okay, so usually we would distribute and, then go ahead and do that. But in this case, I noticed that 3 and 18, they're 3 divides into 18. So isn't this just 3 times what, this quantity? So I can divide both sides by 3 here. And I get 2x plus 5 is less than or equal to 6. Subtract 5, 2x less than or equal to 1, divide by 2. So the first condition is that x has to be less than or equal to 1/2. Okay, so that's one of them. Then the other side, I guess I'll use a different color, I don't know. I do the same thing. Okay, I can divide by 2. X minus 7 is less than negative 3. Add 7 to both sides. I get x less than positive 4. Some positive 4. Okay, yeah. So then I get x less than a positive 4. Okay, yep. So then what does that mean? So if these both have to be true, I have here x, here's 1/2. Okay, 1/2, it has to go to the left. And then I have the other less than 4. So let me show you both. And then basically we're going to only keep the part that highlights both of them, okay? Sorry, excuse me. So this one is 3 times the quantity. Okay, fine. So we have here this part right here, x less than or equal to 1/2 is right here. I did it in red. I'll reverse. So then x less than 4 would be 4, and then open circle, and then in this direction. But because we only care about the overlap, we're only gonna, this is our solution. It has to fulfill both requirements. So in interval notation, we would write that as negative infinity, comma, up to 1/2 inclusive. Okay. All right, let's do another one here. We have 1/3 x minus 4 is greater than or equal to -2, and -2 times the quantity x minus 3 greater than or equal to 4. Okay, so for the first one, we go ahead and solve for x. 1/3 x greater than or equal to 2, multiply both sides by 3, we get x greater than or equal to 6. So that's one of them. And here on this side, I'm going to distribute this time, even though I could divide. I'm just going to, so that you guys see both. Greater than or equal to 4, subtract 6. Okay, -2x greater than or equal to -2, divide by -2. What happens when I divide by -2, you guys? It means, yes, of course, I can't hear you, but I can imagine you saying, flip the inequality. So yes, you're right. So there's two conditions. It has to be less than 1, but greater than 6, okay? It has to fulfill both, okay? So it has to be both. So let's go ahead and graph both, and then we'll see where the intersection is. So I'll graph one in red and one in blue. So this one in red, x greater than or equal to 6, so 6 is over here. X is greater than or equal to, looks like this, right, in this direction. Okay, x less than or equal to 1, so 1 would be over here, and then less than or equal to 1 is to the left. Okay, now question, do these intersect in any way? They do not, right? There's no intersection. Like there's no place where it's both red and blue. So since that's not, there's no intersection, or there's no numbers that make both inequalities true, because this is an and, there is no solution. It has to work for both inequalities. Okay, so this one's no solution. All right, so this is another way to look at the ands. Okay, it looks like this here, a double inequality. It's a compound inequality, and it has in between. I think we did one problem like this last section, so I'm glad we're talking more about them. So you can have x between a and b. It's the same as, a is x is less than, greater than a. So in other words, let me go ahead and show you the graph, because that would be good. So this one, you have A, you have B. It's in between, but it does not include the endpoints. Okay. The next one does include the endpoints. You have A. A and B are arbitrary, like who cares what they are, just, and so it's in between, but including the endpoints. If X is less than A but greater than B, okay, so that's the same thing. You can take it apart. If this is written, it depends on what this is written as. Like it's usually, then B would be less than A, like that. Open circle, and then with the assumption that B is less than A. So then these would be together. Okay, let's see. Alternatively, these two could also be seen as, just depending on what the value is. So this isn't, yeah, so I will go ahead and go through that with you. Here we have, okay, so, yeah, okay. We have here -4 is less than or equal to 3x minus 7 less than 8, okay? So we have -4 less than or equal to 3x minus 7 less than 8. So how do we solve this? We can split it into two, or this is another way, we can just add or do every operation to all three sides, because notice you have three sides here. So 3x is in the center. 8 plus 7 is 15. Negative 4 plus 7 is 3. Let's divide everything by 3 because it's not negative, so we don't have to change anything. So this is 5. Oh, sorry, this is not an equal to. It's just less than. And this is 1. So x is in between 1 and 5. So you have 1, you have 5. We include the endpoints, and there it is. Interval notation, 1, comma 5. Okay. Let's talk about ORs now. OR is a little bit more flexible than AND. So basically, in order for it to be a solution, it could fulfill either one, either inequality. Okay, so it's really important. Sometimes we use a union to connect the two sets. So let's go ahead and do one. So 5 minus 3x less than or equal to negative 1, or 8 plus 2x less than or equal to 5. So I'm going to change the color. So negative 5, so I'm going to go ahead and solve the first one. Negative 3x less than or equal to negative 6, divide by negative 3, and then of course we know by now x greater than or equal to 2, we flip the sign, okay? So that's one of them. Let's go ahead and solve the other one. We get 2x less than or equal to negative 3, and for those of you that are saying, hey, flip the sign, no. We do not flip the sign just because we see a negative, okay? Please do not do that. Otherwise, we would be flipping all the time. You only do it if you're dividing or multiplying by a negative number. In this case, we're dividing by a positive 2, so we do nothing to the inequality. It stays the same. Okay, so this is negative 3 halves. Okay, fine. So let's go ahead and draw our number line, yeah? So I'm going to try to see if I can do this here. Draw the number line. And I'm going to separately draw the inequality so you can see here. Okay, so with blue, x greater than 2. So you have 2 here, greater than or equal to. So here's 2. It goes to the right. Okay, that's the blue part. Now, this one, x less than or equal to negative 3 halves. So negative 3 halves equals, and then to the left. So these, since this is an OR, you basically want the union of these two sets. In other words, it can be either one. It doesn't have to be both in order for the problem to be true. So how do we write this using interval notation? I'm glad you asked that. So you would just go ahead and look at the graph. So from negative infinity to negative 3 halves, we including 3 halves, or so we would write a union to 2 to infinity, okay? So that union is basically saying, hey, it could be on this side or that side. Let's do another one here. We have 2/3. I'll do the colors. Why not? I like colors. Okay. Maybe I should use pink because I like pink. Okay, pink. 2/3 x minus 4 less than or equal to 3. Or, and then 1/4 x plus 8 greater than or equal to negative 1. Okay, so let's start here. Let's go ahead and solve for x. We get 2/3 x less than or equal to 7. Multiplying by the reciprocal gets rid of fractions. Let's not forget that. These cancel out. We get x on the left-hand side of the inequality. Okay, so when we have a whole number multiplied by a fraction, remember you write it over 1 and multiply across. That's 21/2 today. Let's go ahead and do the OR part. So here we have 1/4 x plus 8 times the quantity x plus 8 greater than or equal to negative 1. I can get rid of this fraction by just multiplying both sides by 4. Okay, so that cancels this here. You get x plus 8 on the left-hand side. Negative 1 times 4 is negative 4 today. Okay, I didn't multiply by a negative, so I left the sign as is. Subtract 8. You get x greater than or equal to negative 12. So here's my two inequalities. So let's go ahead and draw a graph. So I have here this, and I'll start with this one. So 21/2, in my mind, I'm thinking, what's 21/2? That's approximately 21/2 is actually equal to 10 and 1/2, right? Or 10.5. So fine, 10.5 or 10 and a half, 21/2 is right here. Solid. I'm going to graph to the left. Okay. So that's all the pink part. Now I'm going to go ahead and graph this one Same number line, but I'm going to do it in blue. I have here greater than or equal to -12. So -12 is like over here somewhere, right? And it's x greater than or equal to, so including, and then it goes to the right all the way to infinity. So that's interesting. So since this is an or, all of this applies. Like it all is a part of the solution. It could be either in this pink set or in this blue set. So if the whole number line is covered, your answer is negative infinity to positive infinity, and that's it. Okay, so that's it for section 2.6. You can either do odd or every other odd. Okay, good luck, happy studying, and I will see you in the next video.